Hi, my name is Sumit, and I'll talk to you about Wildlife Watch. This is a web app I developed for my project in Insight Data Science. There's very large industry around tourism at national parks, and this web app I developed is tapping into that market. What that does is it helps tourists who are visiting national parks get a better idea about what animals are going to be there in the national park for a specific time of year and also a specific trail that they're planning to see. So it's a way for visitors to get a better idea about what animals they could see and which trails they could go to see. So the data I got is from the National Park Service and from alltrails.com. And the National Park Service has an inventory of the different species that are in each of their national parks. So here you can see a lot of the labels that they use for the population of each animal. So some will be abundant, some will be rare. Then from alltrails.com, there are a number of comments, many thousands of comments posted by hikers, which talk about, in some cases actually talk about what animals the visitors saw. So I wanted to use a combination of this data set to get that insight on what animals the users could see in the park. So what I did for my project is I did a significant amount of web scraping, getting the species abundance information from the National Park Service using web scraping, Beautiful Soup and Selenium. And then I also used the same software, Beautiful Soup and Selenium, with alltrails.com to get all the comments for a select number of national parks. Then I performed natural language processing on the comments by tokenizing and lemmatizing, classifying each individual comment as a sighting of an animal or not. So the idea is that for every animal, we want to see what the score is for how much the animal was seen in the comments. So the way that I handle scoring is that if a comment mentions an animal, and if it also has some strong word that's like, I saw the animal or I encountered an animal, then that increases the contribution of that comment to the overall score. So you multiply by 1.5 times. If there's no strong word about actually seeing an animal, but then there is some mention of some animals, then it's just half of that is counted to the score. And if there's words that are indicating that there was no sighting, I did not see a bear, for example, then that contributes 0 to the score. Okay, so overall, this prioritization is done for all the animals in all the parks for each trail, for each season. So the way that I validate my scores is that I compare the scores that I get from my animals against the species abundance that the National Park Service provides. So you'd expect that for a higher score, that the animal might be more abundant, more populous. This is just for a particular trail that's more moderate. It provides a good sample size and a good sampling of comments that might talk about a variety of animals. So here we see that at least when there is a score, because there are many animals for which there is no score, because nobody is talking about certain animals. When there is a score, it's non-zero, above 0, then first of all, those animals tend to be more abundant. And when we do this linear regression, you see that there is a very weak but positive correlation showing that the population does go up with a higher score. And the R-squared is kind of low, but still there's a significant p-value showing the positive correlation. Let me start the demo. So it's right here. This is Wildlife Watch. And first you select a park. Let's say we go to Big Bend and you go there in April. To tell you a little bit more about myself, I got my PhD in electrical engineering and computer science. I worked most recently in the semiconductor industry at AMD. At AMD, I analyzed high-volume manufacturing data and improved the yields. During my PhD, I developed software for analyzing simulation data and doing image processing. I also interned at companies like NASA, where I've done some geospatial analysis. These experiences have led me to my overall interest in data science.